grade 9s. We're going to look at similarity, another topic under geometry of 2D shapes. And we have started with similarity last year already in grade 8. I hope you can remember some of the basics. Otherwise, we're going to run through all the rules pertaining to this in any case in this video. Okay. Similarity of two triangles is normally when you say that two shapes are similar, it means that they are the same shape, but they're not the same size. So when you look at these two triangles, you will see that the yellow one and the purple one, they are the same shape, although the yellow one is much bigger, so they're not the same size, but they are the same shape. So that means that they are similar. The first way is to prove that both triangles share the same angle sizes. And the reason that we use for this is angle, angle, angle. As you can see in the green triangle, it's got a 90-degree angle as well as in the yellow. So one angle is already the same as the other one. Then both of them also share a 60-degree angle. And now the third one was not given. When the third one is not given and you can prove 2 out of the 3, don't you think that automatically the third one is then equal to each other? So let's just have a look. So if we have the green triangle, 90 plus 60 is 150. So what would that third one be? It would be 30 degrees. Let's look at the yellow one. If you've got 90 and 60, it will give you 150. What would the third one be? 30 degrees. So when you look at triangles and you are trying to prove that they are similar and you are using the angle, angle, angle reason, then you only actually have to get 2 angles the same from the one triangle to the other one. The third one then is automatically the same. And the reason that we use here is interior angles of a triangle, because we know that the interior angles of a triangle all add up to 180. And if 2 out of the 3 is the same, that third one will automatically be the same. Okay, the second way to prove that two triangles are similar is proving that all sides are in proportion. Okay, so the first one was angle, 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 proving that all 3 angles are the same from the one triangle to the other triangle. And then the second reason that we use is proving all sides are in proportion. But before we go and have a look at this, we have to understand one very important thing about similarity. The order of the write-up is so very important. Okay. So the order that they ask you, or they say to you, prove that that triangle is similar to that triangle. The order of it is so important. Okay. So if they say prove that triangle ABC is similar to triangle PQR, okay, let's have a look. Can we prove it by angle, angle, angle? No angle sizes were given. So the only other way is through sides in proportion, but also the other way around. If they ask you to prove that two triangles are similar and if you don't have all the sides lengths, then you cannot use sides in proportion. Okay, so if one of those sides were missing, you cannot use it to prove that two triangles are similar. But luckily for this one, we have 30, 40, 25, and with the other one, all 3 sides, the length of it, 50, 80, and 60. So we can use all sides in proportion. So let's have a look at how the write-up works. Which they write the names of the triangles is very important. And I always call it the smiley face write-up. Okay. The length of AB would be in proportion to PQ, the length of PQ. And the length of BC would be in proportion to QR. So the first 2 is related to the first 2 of the second triangle. The second and the last is related to the second and the last. And then the first and the last is related to the first and the last. So it always looks like a little smiley face. Sides in proportion. So they said prove that, and I just want to get my cursor going here, pointer, sorry. Okay, so prove that triangle ABC is similar to PQR. So to do this write-up, you're going to say AB over PQ must be equal to BC over QR must be the same as AC over PR. And sorry, I just saw that I just wrote the bigger triangle first. Okay, so it doesn't matter. So if you start PQ over AB is equal to middle and last, QR over BC must be the same as PR over AC. And then all you go and do is you go and replace the lengths there into the triangle side that you've written up. So PQ, there's PQ, was 60, and over AB, AB was 30. And 60 over 30 is 2. Then QR, QR over there is 80 over BC, which is 40, and 80 over 40 gives you 2. PR, PR is 50 over AC, which is 25, and 50 over 25 is 2. And once you get the same number, that means that those two triangles are similar because of all sides in proportion. So you're going to do your write-up, you're going to work it out, you're going to see all the numbers give the answers here are the same. So your statement is that triangle ABC is similar to triangle PQR. Please keep your order the same as what they've given you. And your answer or your reason there is all sides in proportion.